Okay, so I wanted to kind of finish up and clarify where I left off on the last video. I can only record 15 minutes at a time, so that's why we just kind of cut off abruptly. So I got rushed there at the end, so let's kind of rework the last part of this problem and make sure we have a clear understanding. So we're given two functions. F of x is the square root of 4x minus 3, and we decide that we can't have a negative under that root, so the domain of that f of x was numbers greater than or equal to 3/4. G of x was 6 over x minus 7. We can't have 0 in the denominator because it's undefined. So we decided the domain of g was all real numbers except 7. So those are two independent functions. Okay, and they have their own domains. So then we came down and we found f of g of x, which happened to be the square root of 24 over x minus 3, and then also, 24 over x minus 7, and then also minus 3 all under the square root. So that's what f of g looks like. Now, the idea here is that g is calculated, and then that result is put into f, and then f is calculated off of g. So if g can't be calculated, theoretically there's no way to continue. So we need to make sure that we can get real numbers out of g and out of f. So we already are limited to the domains of f and g. But let's see if the new f of g creates anything new. So in this case, we have a square root, so let's let things under the square root be greater than, things under the square root be greater than or equal to 0. So as I clean this mess up, that'll look like 24 over x minus 7 minus 3 will be greater than or equal to 0. So in solving that, we can bring the 3 over. And now that we have a rational thing here, we can multiply by x minus 7 to get rid of some things, the denominator. So we'll have 24 greater than or equal to 3 times x minus 7. And if we clean that up and solve it, eventually we get down to x is less than or equal to 15. So that is f of g that we came up with. But now we've got to kind of put that in line with the other things. Okay. So we have to take into account what f limitations were, what g limitations were, and if we get any new limitations by putting them together. So just let me kind of draw a number line here and see if we can make sense out of it. Okay, so on a number line, I'm going to put 0 over here since all the numbers I'm looking at are positive. So I've got three numbers here. I've got 3/4, I've got 7, and I've got 15. So based off of things that we see here, we cannot use 7 out of g. So I'm just going to put me an open circle here. 7 is out of the question. From f, I can use numbers greater than or equal to 3/4. So over here is the 3/4. Greater than or equal to will go to the right, and it could keep going forever except for when I did the composite, I can only use numbers less than or equal to 15. So that's less than or equal to 15. So really the numbers I am limited to with this new square root function are between 3/4 and 15, but not 7. Okay, so I kind of combined all that together. So the way you could write that in interval notation would be bracket, it's a positive 3/4, we'll just go ahead and change it, up to 7 with a parentheses, and then combine that with from 7 on to 15 with a bracket. So any of the numbers listed here or highlighted on the number line should work in our new composite function, and should also make sense if we look at it as the individual functions given inputs to the next. Okay, so that's a little bit clearer, I hope.